Hello everyone. The question is the figure shows a circuit having each resistor 1 ohm each labeled from R1 to R8. There are the 8 resistance which figure shown as given R1, R2, R3, R4, R5 is something. This is the 12 volt and this is the 6 volt. And in this configuration there are the two batteries are connected. This is the 6 volt and this is the 12 volt, and there are the 8 resistance are given, and E1 equal to 12 volt and E2 equal to 6 volt. This is the 12 volt and this is the 6 volt. There are the 8 resistance are given. We have to require the magnitude of current flowing through R1 equals to, this is the R1 and this is the R2, this is the R5, R8, R7, R6 and R1, R2 and R3. I think this is the R3 resistance. Okay. Then we have to calculate the value of magnitude of current of R1 resistance. This is the R1 resistance and R2 resistance, R3 resistance and R5 resistance. We have to need the magnitude of current for these 4 resistance. Okay. So we are trying to solve for this circuit. The circuit are shown in this figure. Here we look carefully. What will be happened? Let us suppose this is the A point, B point, C point and D point and O point. O point is the junction point, A point, B point, D point and C point. We are trying to find the potential difference between A and B and A and C. Okay. So we are trying to potential difference for this point. This is the battery, this is the 6 volt. So this is the current is flowing from negative to positive. This is the, let us suppose I1. So this is the I1 by 2, this is the I1 by 2. Okay. So here R6 are given. They are the each resistance equal to 1 ohm. So potential difference between A and B, what will happen? VA minus I1 by 2 into 1 equal to VB. Similarly, A to B, VA minus I1 by 2 into 1. 1 y R5 equal to 1 ohm equal to VC, implies that VA minus VB equal to VA minus VC, implies that potential difference between A and B equal to A and C. A and C. Okay. So implies that we can say R6 and R5 will be in parallel. R6 and R5 will be parallel. This is the 1 ohm, this is the 1 ohm. Then if any two resistance are in parallel, implies that R equivalent equal to R1 into R2 divided by R1 plus R2. 1 into 1 divided by 1 plus 1 equal to 1 by 2. 1 by 2 equal to 0.5. Implies that this is the, let us suppose this is the final configuration. Final configuration implies that we can say, let us suppose this is the circuit, this is the R3 and this is the also battery is connected, and let another point which will be equals to this configuration, and this is the resistance, this is the resistance R2. Also this is the given, this is the R6 and R5 will be in parallel, implies that, let us suppose this point, what will be happened? 1 by 2, 1 into 1 divided by 1 plus 1 equal to 1 by 2. Because potential difference are equal, implies that R5 and R6 will be in parallel. So we can say equal to 0.5. 0.5 is the combination of R5 and R6 are in parallel, implies that. Another point, what will be happened here? This is the R8 and R7. Similarly, VB minus VD, VC minus VD, or VB difference VB, VD, VC difference VD, which will be equal to same. Implies that potential difference between R7 and R8 are in same. If potential difference are in same, implies that resistance are in parallel. So 1 and 1, they are the same resistance. Similarly, we can say combination of R7 and R8 equal to 0.5. So this is the 0.5 resistance, this is the 0.5 ohm resistance. Okay, now here we can say this is the R4, similarly this is the R2. What will be same will be value will be happened, VB difference VO equal to VC difference VO, which are the same potential difference. Similarly, because VO equal to VO and VB equal to VC, implies that we can say VB difference VO equal to VC difference VO, which will be same. So we can say these also R2 and R4 are in parallel. So 1 into 1 divided by 1 plus 1 equal to 0.5. So this is the alpha resistance with what will be happen the 0.5. This is the 0.5. Okay. So this is the 0.5. Now this is the R3. This is the R1. This is the R1, R3. R1 and R3 cannot be changed. This value equal to 1 ohm, this value equal to 1 ohm, and this value equal to 1 ohm. Now this is the first path, closed path, this is the second path. Let us suppose this is the 6 volt battery, this is the 12 volt battery, and current flowing through the 6 volt battery equals to I1. So this is the I1, also this is the I1, and also this is the I1. Similarly, this is the 12 volt and this is the I2. This is the I2. This is the I2, implies that. So this is the I2 and this is the I1. I1 is here and I2 is here because this is the 12 volt battery and this is the 6 volt battery. So current I2 is more effective compared to I1, or we can say I2 is greater than I1, implies that this in this branch the current will be flowing I2 minus I1. I2 minus I1, in this branch current is flowing is the upward direction, which value equal to I2 minus I1, because this is the 12 volt battery and this is the 6 volt battery. So 12 volt battery is more effective. Current is flowing through the 12 volt battery is close to I2. A current is flowing through that 6 volt battery is I1. So I2 is more effective compared to I2 is more effective compared to I1. So I2 minus I1 implies that. Similarly, we can say in this branch the current is flowing through the I2. This is the I2 and this is the I2. This is the I2. Okay. In this branch I2 minus I1. In this branch this is the current is the I1. Okay. So we are using the KCL. KVL, Kirchhoff current law. Okay. Now try to solve the Kirchhoff current law. What will be happen? Let us suppose this is the A point. A point. So we are trying to solve the from the A point. VA and current is flowing if we are moving along the current. So that will be the potential drop. This is the minus IR. Current is flowing to this direction. So this is the current I1. I1 is unknown. This is the 0.5 resistance. So minus 0.5 into I1. Right. Minus 0.5 into I1. Because we are moving in this direction. And if we move the current is flowing upward and we are moving the downward, so this is the positive, not a negative. So we can say this is the plus sign of 0.5 into I2 minus I1. This is the I2 minus I1 and we are moving in this direction. This is the along, this is the R3. R3 is the 1 ohm resistance and current I1 is flowing. So this is the along the current are moving, implies that minus 0.5, or we can say this is the 1 ohm into this is the I1 current is flowing, and this is the negative, this is the positive. We are crossing negative to positive plate, implies that that value equals to plus 6 volt is equals to VA. We are cancel out the potential is the VA. Similarly, we can say 0.5 I1. We are try to solve the 0.5 I1. Right here 0.5 I1 multiplying up the number of 0.5 I2. Similarly, we can say 0.5 I1, this is the I1, this is the plus 6 volt equal to 0. 0.5 I1 minus 0.5 I1 minus 0.5 I1 minus 1 I1, I1 and I1 minus 2 I1, imply that we can say 2 I1 minus 0.5 I2, which value equals to 6 volt. This is the equation number first. 2 I1 minus 0.5 I2, which value equals to 6 volt. Similarly, we are using the KVL for the second closed path. Okay, if this point is the D point, so trying to solve D point, D to this direction, imply that due to this direction, imply that we can say VD minus I is the I2, resistance is the R, so we can say 1 into I2, implies that negative positive, this is the plus 12 volt, and this is the 0.5 resistance, and that value equals to I2 minus I1 minus 0.5 into I2 minus I1 minus I1, so 0.5 I2 minus I1. Here this is the minus, this is the 0.5 into I2, this value equal to VD is the cancel out, implies that you can say minus I2, and this is the minus 0.5 I2, here minus 0.5 I2 minus 0.5 I2 minus 0.5 I2 1 I2 minus के साथ में minus 1 I2 तो minus 2 I2, similarly we can say 0.5 I1 implies that we can say this is the plus 12 volt. Simplifying the number of 0.5 I2 terms, what will be happened? 2 I2. Similarly, we can say this is the plus, so minus 0.5 into I1, which value equals to 12 volt. This is the second equations. So we are find out the value of I1 and I2. Find out the value of I1 and I2. There are the two equations, 2 I1 minus 0.5 I2 equal to 6 volt. This is the 2 I2. This is the 2 I2 minus 0.5 I1 minus 0.5 I1 plus this value equals to 12 volt. This value equals to 12 volt. Okay, try to find out the I1 and I2. Then what will be happened? If we try to find out the I1, then multiplying of a number from first equations, this is the 2 number, so 5 4 ja 20, multiplying of a number 4 in equation first, because 5 4 ja 20, 2.0, so adding these equations, then I2 terms will be cancelled out, implies that number equal to 4 2 ja 8 I1, this is the minus 2 I2, and that number equal to 24. Next, minus 0.5 I1, this is the plus 2 I2 equals to 12. Okay, so we are added this point, so I2 will be cancelled out. This is the 8 I1, here this is the 7.5 I1 equal to, this is the 6 number and this is the 3 number, implies that I1 equal to 36 divided by 7.5, this is the 0, so cancellation the point, So what will be happen? 5 5 1 ja 5, 5 5 ja 25, 5 7 ja 35, 5 7 ja 35, 5 2 ja 10, implies that. Next, what will be happen? If we divide the 15, divide by 15, then cancellation the number 3, then 3 5 ja 15, then 3 2 ja 6, 3 4 ja 12, 3 4 ja 12. Next, 5 5 4 ja 5 4 ja 20, then 5 8 ja 5 8 ja 40, 5 8 ja 40 ampere, implies that I1 equal to 4.8 ampere. I1 equals to 4.8 ampere. I1 equals to 4.8 ampere. Okay. Similarly, we have to find the value of I2. So we have to find the value of I2. Putting the value of I1 in these equations, then what will be the I2? Then what will be the I2? Okay. So these equations, putting the value of I1 in second equations, then 2I2 minus 0.5 into I1. I1 will be the 24 divided by 5. 24 divided by 5. Then 5.1 equals to 2.4, equals to 2.4. So dividing the number of 2, then 2.4 divided by 2 equals to 1.2. So I2 equals to 1.2. I2 equals to 1.2. Okay. I2 equals to 1.2. Okay, I2 equals to 1.2. Now check the value, the magnitude of current flowing through R1. R1 is what? R1 is here, then that is the current I2. That is the current I2. Then R1 equals to 7.2. R1 equals to 7.2. Then in place of a R1 resistance, then what will be value? Will be the 7.2. Then 7.2 is this number. So here I2 equals to 7.2. Then this will be the added value. Then what will be the happened? Then this is the 5. This is the 2.4. 1 minute. 24 to I2 minus 0.5 equals to 12. Here, 1 minute. This is the 12 volt. So this is the 12 plus. This is the 2.4. 2.12 plus 2.4. What will be the happened? Here this is the 14.4. So 10.4, this is the 2 times. Then I2 equals to 7.2 ampere. 7.2 ampere. Okay. So I2 is the what? I2 is this. According to R1, then 7.2 ampere. So A is the correct option. Okay. Next point. R2. R2 is the what? And R2 is this number. R2 is this. And I1 in R3 resistance. I1 equals to 4.8. Okay. I1 is the 4.8. Okay. A is the correct and R3 is the correct. And we are checking the R2. And R2 will be what happened? R2 will be the R2, according to R2, then here current is flowing. What will be happened? Current is flowing. This is the totally current is flowing I2 minus I1. 1 minute. This is the current is flowing I2 minus I1. I2 minus I1. I2 minus I1. Then 7.2, 4.8, 4. Here this is the 6, 2 ampere. So in this circuit, the current will be 2.4 ampere. But here we are looking as if this is the current I2 minus I1. If this is the I2 minus I1, we are distributing the in two division. This is the I2 minus I1, I2 minus I1 divided by 2. Similarly, I2 minus I1 divided by 2. So in this circuit, in this resistance R2, in R2, current is flowing I2 minus I1 divided by 2. So 2.4 divided by 2 equal to 1.2 ampere. So in R2, current equal to 1.2 ampere. That is the correct option. In R5, what will happen? In R5, in this circuit, the current I1 equal to 4.2 ampere. 4.2 ampere. But if this is the current I1, but here this is the current is the I1, this is the I1 in this circuit, this is the I1 by 2 and also this is the I1 by 2. Okay, so divided by आपका I1 2, तो 4.2 divided by 2 equal to 2.4. So R5, in R5 also 2.4 current is flowing. So option A, B, C, D are correct. This question is the advanced 2022.